Today, very, very easy. Let's first talk about that worksheet that's due tomorrow, correct? Let's take that out. Let's actually take a look at it, okay? That's what I was talking about right now.
I'm actually confused on number 13.
Okay, 13. All right, these are good things. Let's talk about them right now. Yep, this is good. There we go. Open it up. Let me put it up on the board here for us. We talk about these things first, so we can get some time. Okay. So we'll talk about this before lunch. After lunch, we're going to do something completely different. So, that's what I want to do today. I don't want to go too far in depth. We're missing quite a few people today. You have to watch the video, so it's just the same. Great. Here's our sequences. Remember, you have to tell me the type, tell me the missing value for the blank, and then find the next two terms after the blank or like at the end, very end. Okay? So, page, I know we had what? It was 1 through 8 on the first page. Any in particular you're not quite getting? Like, I just didn't know. What do you got?
4.
Number 4. Let's talk about 4. Okay. All right. Now, do we agree the numbers got really big really fast?
Yes.
It literally went to 93 in a matter of 5 numbers. There's got to be some form of multiplying then, if it goes that big that quickly. Okay, so here's what I noticed. Okay, I'm going to do the common difference first. So it's going up by 6 plus 1 plus 20 plus 1 plus, what is that, 62? So at some point you probably noticed something here. It looks like the pattern is it's multiplying by something, it's adding 1. Multiplying by a number, adding 1. Multiplying by a number, adding 1. So what would be my next number? Say it again?
Multiplying by 3.
Multiply by 3. 3 times 3 is 9, plus 1. Multiply by 3 gets me to 30, plus 1. Multiply by 3 gets me to 93, which is correct. Then add 1. So what's 93 plus 1? There's a blank. Okay. Then what do I have to do right after the plus 1?
Times 3.
So we have to take that number times 3. So 94 times 3. That's a 12, 1, 2, 82. Then what do we have to do after that? The 1, so we're at 283. Okay. Questions, comments on that problem? That was a good one. Okay, do you see how, like, you can kind of tell if they're multiplying by, like, how big the numbers are getting really quick? I can kind of tell, like, they have used some pattern there. Then multiplied by 3 plus 1, multiplied by 3 plus 1, yeah. It looks like that's the pattern the whole entire time. Okay, now what type of sequence is that? Yeah, it's a typical one. So it's just, I would just mark it as a sequence, right? It's a typical sequence. There we go. Sequence, we have the number, we have the next 2, we're good. Go on to the next week. Okay, that'll be up. Any others on the first page through 8 that maybe you just didn't quite get it? Maybe you haven't had time to look at it yet. All right. No questions there. Let's flip to the back. I know we had one on the back that we had a question on. Was that 13? Let's start there. 13. See if the pattern works. See if we have a pattern. Maybe it doesn't. 13. Okay. Okay. So 13. Let's. Okay, we have minus 1, minus 4, and something, minus something, minus, we got 13, minus 16. Okay, so it's definitely, it looks like it's definitely going down. It's not multiplying. The reason why, the numbers aren't getting very big or very small very quick. We're definitely not multiplying or dividing. We're just subtracting by something. So if you notice, are my gaps changing? Yeah, so it looks like this is a normal sequence, right? It's just a typical one. Okay, it's not arithmetic. It's not jumping about the same number every time, right? All right, but now, let's look at the gaps. How are the gaps changing? Like, what was the gap difference going from 1 to 4? It was, what, getting 3 more? Let's continue that pattern. Let's go minus 7. So this number would be 72. No, 73. Sorry, 73. Then we'll go 3 more. What is that, minus 10? 63. That's it. It's going down by 3s every time. So what will the next number be? What am I going to subtract? If it's 3 more. What's 3 more than 16?
13.
3 more.
Oh,
So that's what we're going to go down by. Then the next one will go down by 22. So that's 3 more than that. Maybe keep going. All right, does that make sense? Like the pattern? There was a pattern. It was growing by 3 more every time. So we got 4, so we got 7, so we got 10, 13, 16, 18, 22, 25, 28. It would just keep going. questions on this? And I think you can figure out the next page. Any other questions on this page? You only had a couple on this page. What, 7 on this page? 9 through 15? 6, 7. You didn't quite get, do you just need more time? 15? I think that was a goofy one, wasn't it?
Yeah.
But if I give you 2 more numbers, you'll probably see the pattern. I cut it off a little short. It's kind of hard to see the pattern now. All right, so 15. So it looks like it's going down, not very fast either. Okay, so down by 8. Down by 8. This is laying down by 12. Down by 8. This number, I told you was 56. That's what I told you yesterday. That was your number here. That's going down by 8. So what do you think the next number is going to be?
12.
Down by 12. 42. What's the next number going to be?
8.
Down by 8. It's going down by 8, down by 8, down by 12. Down by 8, down by 8, down by 12. Down by 8, down by 8, down by 12. It's just hot. It's just hot testing. I should give you that extra number because then you can notice the pattern. It's 8, 8, 12, 8, 8, 12, 8, 8, 12. And this is just a sequence. It's a typical one. It's not arithmetic. It was almost arithmetic. That little 12 threw it off. I should have given you that one extra number because otherwise you couldn't tell the pattern without that. I cut off one number short. I should have kept going. The book had all those numbers, but I should have just kept going. I didn't even think about that. Okay, questions? Okay, I'm going to give you some more time here. So you got about 12 minutes here. You can kind of work on this. Then we'll go to lunch. We'll come back and we'll start something new today. It's not really new, it's kind of a review, but it's a topic that we do need to talk about. We just have a couple notes here once Hannah gets back here, and then we're done for the day. And it's something we've already talked about. I just want to make sure we cover it one more time. 2.6, we've mentioned a little bit. Make sure right now that you have your multiplication chart in front of you. You're going to need that right now. Okay, we're just going to do a few notes here. Make sure you have your multiplication chart out. We're going to do the divisibility test one more time. This is a part of the sets. So when you have a set of numbers, you can check whether they're divisible by these numbers really, really quickly. Now notice we don't have like the number 8. We don't have the number 7 in this list. We don't have rules for them. You just kind of have to know the multiples of 7 or know the multiples of 8. But we definitely know the rules for these. Okay? So for instance, how do you know if a number is divisible by 2? Yeah, it's got to be even. That's basically the best way to put it. Is your number even? So basically, that's a big fancy way of saying does your number end, or digit end with a 0, 2, 4, 6, or 8? That's it. I mean, so somebody create a number that ends in one of those.
238.
238. Okay. Do we agree that it ends with a 0, 2, 4, 6, or 8? It's divisible by 2. What I mean by that is if you actually divide it by 2, you will not get a remainder. So 2 goes into 2 once. 2 times 1 is 2. Subtract, you get a 0, bring down the next number. 2 goes into 3 once, which is a 2. You subtract, you get 1. Bring down the 8. That's 18. 2 goes into 18 9 times perfectly, giving you a remainder of 0. And that's that whole idea. So, no matter what number you create, you can tell if it's divisible by 2 because it has to end in 0, 2, 4, 6, or 8. All right. That was one of the rules we discussed previously. Is there any questions with the number 2? All right. Let's move on to the next one. How do we know if a number is divisible by 3? That the number 238 is not divisible by 3. It is not. Okay? A number that could be would be the number 438. 438 is divisible by 3. I can tell you that. I can promise you that it's divisible by 3. What about 102? That's divisible by 3. Or say 711, divisible by 3. Here's how we know. When you add up the digits, like the number, so in this case I'm going to use 3-digit numbers, right? When you add up each digit, that number that is resulting in the very end is a multiple of 3. So if you look at your multiplication chart, so look where the 3's are. Okay, so look at the row with the 3's. The rows are the ones that are going horizontal, right? So if you're looking at the 3 here, any of these numbers, if you add up your digits and then makes any of the numbers in the row with 3, that means 3 goes into it. Does that make sense? So when I add up this number, 4 plus 3 is 7 plus 8, which makes 15. Is 15 in your list of 3's?
Yes.
So it's divisible by 3. That's how it works. That's why the multiplication chart is so handy. Okay, so now to prove my point, let's actually show that it is divisible by 3. So 3 goes into 4 once. Subtract, I get a 1. Bring down the 3. 3 goes into 3 4 times, which is a 12. do you get when you add these three digits together? Add them.
Oh, 102.
1 plus 0 plus 2.
Oh,
3. Is 3 in your list of threes? Yes, it is. So it's divisible by 3. 7 plus 1 plus 1. 9. That's in your list of threes. So it's divisible by 3. Can you make up a new number? Any number in the world.
60.
68? Okay. So 6 plus 8. 6 plus 8 is 14. Is that in your list?
No.
No. So you gotta add another number on there. What will make that a number in your list? 69. Maybe just put a 1 on it. That's 15. So you can get creative. You can start combining numbers. You can make any length of numbers that you want. It just has to fit the bill. So divisible by 3 is the sum of all digits is a multiple of 3. Alright, so that's why that multiplication chart is in. Make sense? Alright. Okay, now let's go to the number 4. Alright, for the number 4, if you know your number is divisible by 4, number 1, it has to be even. It has to be. Because 4 has a 2 in it. So if it's going to be divisible by 2, it's got to be divisible by, the number has to end with an even. Okay, it has to end with a 0, 2, 4, 6, or 8. Okay, now the rule is for 4, you look at the last 2 digits. Last 2 digits. And they have to be in multiple of 4. So that means if you look at your multiplication chart, look at all those numbers in the list where there's 4s. Okay? So for instance, Jason, pick any number in that row with the 4s. Any number in that entire row. With the 4s.
28.
28. If you make up any number and you put 20 at the end, it'll be divisible by 4, guaranteed. So I can make up the craziest number. Divisible by 4. Okay. Mr. Ward? Hello? What? That doesn't sound right. I'll go talk to him. No. It should be, once they have the bill, they'll get it paid out, so. I wonder if they have to get it approved by a school board. I wonder if that's why. But that should be soon. I mean, they have a school board meeting on Mondays, so. I'll look into it. Sure. 430-9549. Okay. All right, will do. Thank you. Bye. All right. So on this number we ended with the 28, right? Because that was your list of multiples of 4. This number is divisible by 4. So in fact, I'm going to prove it right now. Okay? Even though this number is really, really long, I can prove that you will get a remainder of 0 in the very end. 4 goes into 7 exactly once. So that would be a 3. Bring down the next number, 33. 4 goes into 33 8 times, which is a 32, which is a 1. Bring down the 7. 4 goes into 7 4 times, which is a 16, which is a 1. Bring down the next number, which is 5. 4 goes into 5 3 times, which is 12. Bring down a 3. Bring down the next number, which is 39. 4 goes into 39. Let's see, 9 times, which is 36. If I subtract, you get a 3 there, so I'll bring down the next number, which is a 4 goes into 36 9 times perfectly, which is 36. You get a 0. Bring down the next number, which is a 2. 4 goes into 2 0 times. 4 times 0 is 0. That's without going over. So that's a 2. Bring down the next number, which is 28. 4 goes into 28 7 times, and boom. There's your number. So it did work out perfectly. You got a perfect remainder of 0 in the very end, and it actually worked out. So what is that? 18,439,907 times. So, and again, you just had to make sure that your last digit was a number that was on the multiplication chart for 4s. Well, that's pretty easy, because you have the multiplication chart, so anything that's past that multiplication chart wouldn't be the last 2 digits. That's why I like having that chart in front of you. Okay, 5. You guys already know the rules for 5. What is it? 5 or 0. Easiest enough. Easy enough. You don't need to worry about it. 6. If I go back to what I had up here for the number 2. Okay, I'm going to go back to what I had for 2. So divisible by 2 and by 3. Okay? Well, if it's divisible by 2, it has to end with a 0, 2, 4, 6, or 8. Okay? Divisible by 3. It has when you add them up, they have to be a multiple of 3. 6 has to have both of these rules. It has to be by 2 and 3. So that means my last digit has to be even. Has to be one of these. And it has to make sure that we add to make a number that is a multiple of 3 on your chart. Okay? So, let's make up a number. Okay? So Jason, pick a first number, please. 5. Next number, please. 6. 7. Okay? Alright, so far, this number is not divisible by 6. Didn't end with a 0, 2, 4, 6, or 8, right? And if I add these up, so far I have 12 plus 6, which is 18. In fact, what if I just put a 0 on the end? Divisible by 6. It's divisible by 2, because it ends with a 0. It's divisible by 3, because when I add up all 4 of those digits separately, I get the number 18, which is divisible by 3. It's on the list for 3s. And it should be divisible by 6. So let's, in fact, I'm going to prove it. 6 goes into 56. Let's see, what is 6 times 9? 54. So I subtract, you get a 2, bring down the 7. 6 goes into that 4 times. 6 times 4 is 24. You get a 3, bring down the next number, 0. 6 goes into 35 times perfectly. And you actually get a remainder of 0. So it worked out perfect. Because if it works out by 3s and by 2s, it works. Do you see how I can combine numbers to make sure that it fits the bill? I knew it had to end with an even, and I just had to make sure that when we add them up, it was on the multiples of 3s. So it's pretty easy to put numbers together. Okay? At some point in here, on tomorrow, we're going to start making up our own numbers. I'm going to give you stipulations. Your number has to be a 5-digit number, has to be divisible by 3 and by 2. Well, by 6. So you can make up all these numbers, and it has to fit the bill. It has to be certain numbers. You got to put all these rules together. So you're reverse engineering numbers. That's what we're doing. Okay. Any questions so far? 9. 9. When you add up all the numbers, it has to be on the list for 9. So look at your list of 9s. 9s are what? 9, 18, 27, 36, 45. So when you add up all the digits, they have to make a number that's on that list. So it's kind of like the numbers for 3. It's kind of like that. When you add up all the digits, but now they just have to be a multiple of 9. So I'll make up a number here. 945. Okay, just a kind of a big number. When you add up all digits, 9 plus 4, what is that? 13 plus 5, that's 18. Is 18 on the list for 9s? Then boom, it's divisible by 9. It's guaranteed. In fact, it's divisible by 9 by 104 times, something like that. 104 times. So it's just kind of a weird number. 105 times, sorry, 105 times. But that's the idea. You just add up the numbers, and they have to be in the list for multiples. There's only certain numbers that number would have to be crazy big to add up to be 27 or 36 or 45. Like when you add up all 3 of those digits. So that's why most of the time is, does it add up to be 9? Does it add up to be 18? Does it add up to be 27? That's what I'm checking. That's the idea. 10. What's the rule for 10? Ends in a 0. That's the only rule. So it's pretty easy. 11 is that goofy rule where when it doesn't matter the length of your number, it's every other number adds to make a number that's equal to the numbers you skipped over. That is the goofy rule. We're going to look at that one tomorrow, not today. Because I want to make sure we review that with everybody. Okay, any questions, comments, concerns on the select few numbers we talked about today? We're going to talk about 11 for sure tomorrow. You need to be ready to go for tomorrow. I know this homework, this worksheet is due tomorrow. Some of you have already turned it in, that's fine. Tomorrow we're going to look at reverse engineering numbers together. Okay? All right. We're done for the day. Very nice, very easy.
What's happening out here?
We're out of here at 29.